All right, so hello everyone. My name is Alex Garcia. This is a online event hosted in the Mozilla AI Discord channel today on October 2nd. Today we will be talking about hybrid search with sqlite-vec. I have a new guide, a new blog post about how to perform hybrid search, which is a combination of full text search or keyword search with vector search or embedding search. A way to combine both of those two together to get better search results for search engines, RAG applications, things like that. It's a new blog post that talks about it. Today we'll be just basically going over what that blog post says in more detail, stepping in through some of the code samples that it has, talk about different embeddings models that you can use and different approaches you could take. That's what today's online event is for. This session will be recorded. If you want to share it with coworkers or friends afterwards, feel free to go ahead. Right now, live in the Mozilla AI channel. If you want to ask questions in the comments, feel free to do so. We will have a Q&A session at the very end as well. If you want to have, if you want to get on stage and talk a little bit more, happy to do so. And of course, at any time during this, or if you're part of this event right now, make sure to join the sqlite-vec channel within the Mozilla AI Discord server. There is a sqlite-vec role that you can join, and with that, you'll be notified every time there's a new blog post or new release about on the SQLite library itself. So be sure and go ahead and subscribe to those to be notified of what's going on. So today, hybrid search. Before we get into the actual meat of this talk, there is a CVE out for SQLite-vec. There is a security vulnerability that was found by a security researcher. So I recommend upgrading to SQLite-vec version 0.1.3 or above. It is a fairly obscure memory vulnerability. You would only access it if you were using either one, using an undocumented SQL feature and you accept malicious input from users, or two, if you run SQL queries arbitrarily from users, both of which are not a good idea to begin with, but if you were, there is a small vulnerability that's available there, so make sure and upgrade. If you're curious of what happened, there was a SQL function for parsing NumPy files. I had some logic in there to parse like a NumPy header. That was a lot of like ugly, disgusting string parsing stuff. Ideally, this code wasn't supposed to be a part of the SQLite-vec to begin with. It wasn't supposed to be a part of the default installation entry point. Unfortunately, I included it in there, forgot to take it out. I was not notified of this CVE. I just found it randomly through Twitter, so kind of wish I got notified in a better way there. I've upgraded some documentation. I have a new security.md file if you do find security vulnerabilities, so that way we could fix them and patch them before they're made public. But otherwise, make sure to upgrade if you are one, running arbitrary SQL, or two, using that undocumented feature. Otherwise, it probably doesn't affect you, but it's a good opportunity to learn how to upgrade SQLite-vec to begin with. So make sure to do that in your projects that are using SQLite-vec. And what we'll be talking about today, hybrid search, this is basically an IRL or a live version of the blog post that I just posted. I will drop a link in the Mozilla chat as well if you want to take a look. Essentially, it is a blog post that goes over how to build a semantic search engine using the built-in SQLite FTS5 extension and SQLite-vec to include vector search in it, and a few different strategies and how you can combine those two together. Let me drop a link of this into the chat if you want to check it out. So go ahead and check that out, share with coworkers if you want. I will also include a page in the SQLite-vec documentation website that talks about hybrid search and it talks about these approaches specifically. So that way it's not just a blog post that's never updated, it'll be part of the documentation page itself. So go ahead and make sure to check those out. Again, this live talk will basically be a walkthrough of this blog post and of the approach that it takes. So not completely necessary to read through if you're going to be sitting through this talk. But otherwise, let's go ahead and jump into it. So first off, there are many different ways to perform search. The most common way has been keyword search. So as an example of a real life version of this, the SQLite forums, which is ran by the SQLite core developer team, they have a search function. If you search in it, you get exact keyword matches, all right? So if you search for, in this case, statically link extension, this is when I was looking about forum posts about how people statically link SQLite extensions in SQLite. I search for that phrase specifically, and I get results that use those exact keyword matches, all right? So if there was a post that used the word static or linking or extension, then it would return in those results. This isn't ideal. It's a little bit hard to parse out, depending on what you search. So for example, maybe I wanted to see stuff about how to compile statically linked extensions. It's kind of implied in my search, but it's not in the exact phrases that I used, so it doesn't appear. So again, keyword search is something that we're used to. It's been around for, decades at this point. I grew up on full text search and on keyword matches. It's kind of what we expect through Google and stuff. So we've kind of learned a way how to work around some of the nuances behind keyword search. But there are limitations to this, right? So keyword search is great, been around for decades, and vector search is a cool new thing. We can do like vibe-based search, right? So when I look for statically linked extension, maybe you could figure out like, oh, maybe I'm trying to compile something. Maybe I should find forum posts where people have SQLite extensions they're trying to statically compile versus dynamically compile. And this kind of vibe or semantic search doesn't exist in full text search, but is something that we do have in vector search. So that is one nice thing that SQLite-vec offers over full text search, and it's a great thing to have. But you also cannot just have vector search. This is an example that I talked about in the blog post. And so this is a real world example. So this is HBO Max. It's one of those many streaming services that we have now. When they first launched, there was this bug where if you search for the TV show Adventure Time, literally just the phrase Adventure Time, that is a TV show. It's been around for like over a decade. A very great TV show, really funny, Cartoon Network, I love it. But if you search for it on the streaming service, it was the 30-second results. So there's a bunch of other searches on top of that, like adventure, like Aqua Teen Hunger Force, or Ghosts, or Rick and Morty, or a bunch of other stuff. Adventure Time was the 30-second result. Why wasn't it the first one? You know, you search for Adventure Time, you expect Adventure Time, right? Now, I don't know exactly what was going on behind the scenes at HBO Max when they first launched and what their search engine was like, but I can imagine that what they were probably doing was vector search, right? Because those first 30 results, if you think about it like in a broad sense, just kind of forget that Adventure Time is an actual TV show. The query Adventure Time can mean a lot of things, right? Like maybe you want to watch a TV show where they go through adventures and they do all this stuff, right? Like they do in Rick and Morty, like those interdimensional space adventures, right? Or all these other TV shows that have adventures. It's technically Adventure Time, but it's not the actual Adventure Time that we're thinking of, right? So this is one downside to vector search, that sometimes when you search for something, it should be an exact match. It should be what you expect, but the semantics kind of take over and you get other results first. So this is what I think happened in, this is what I think happened when HBO Max launched, that they were relying on vector search too heavily to the point where Adventure Time, searching for Adventure Time, was downranked far, far below all these other shows. So again, you can't just rely on vector search, and it's best to have both full text and hybrid search. To have both full text search and vector search for a hybrid search approach, and that is something that we can do using SQLite. Using SQLite, the built-in full text search FTS5 extension, and using SQLite-vec, which is a vector search extension that we have here in the Mozilla AI Discord channel. So as a demonstration, same exact one that we have in the blog post, the one that I will be walking through today. This is a demo of NBC News headlines. So I wrote a little scraper that scraped through NBC News and all the headlines that they have. So, this is the front page of what it looks like today. It gets all the headlines. So these are only, small pieces of text per article, maybe around like a dozen or so words. So it's a fairly good example to use for semantic search because they're very, one, these are headlines that span bunch of different news, right? Like politics, world news, climate change, all that stuff. So semantically, that's a very broad, but also it's small pieces of text, so we don't have to worry about chunking or any of that other stuff, or any of those other approaches that make some search applications very hard. It's just a very easy thing to kind of go through. So that is an example of what we will be going through today. So I'm going to switch over to some code now. Let me switch my screen over to VS Code. So I'll be walking through the entire demonstration from scraping to actually generating the full text search engine and vector search index and everything else, and how to combine the hybrid search. So again, if you have any questions, feel free to comment in the Discord chat. Happy to answer them. But from here on out, I'll be mostly walking through these Jupyter notebooks that we have. All right. So first off, we need a scraper. This is using JavaScript, specifically Dino, and their Jupyter Notebook kernel to scrape the NBC News website. So if you can see that, let me switch my screen again. So NBC News, they don't offer their headlines in a nice, easy to use data set, because why would they? However, what we can build is a scraper that will scrape through. So this is the sitemap that NBC News offers. This is for like search engine optimization for some other reasons. But what it is that they have one web page for every month where they list all the headlines in their like corpus, right? So it's a headline like, men's NCAA Final Four is set with 11th seed, yada, yada, yada. These are linked to URLs to the actual article contents themselves. And for this example, we're going to scrape these sitemaps. All right, so we're going to go from, for 2024, January, we're going to go over to February, March, scrape all those, get all the headlines into a SQLite database, into one SQLite table, and we'll use that data set to build the full text search engine, the vector search implementation on top of that, and we'll eventually build hybrid search based off of that. But this is the core data set that we're looking at. And what this Jupyter Notebook does back over here, this is just a scraper for those. So it will hit those sitemap pages, it'll loop through January, February, March, all that stuff, and it'll load it into a SQLite database using Deno and JavaScript. I won't go into the exact specifics of this notebook unless you're really curious about that. But building a scraper, you can do it in many different languages like Python or Node.js or R or Elixir, or whatever you really want. This is just one implementation that I had just to make it easier, so that way it would fit in a nice little Jupyter Notebook. One nice thing about Deno is that it has Jupyter Notebook support built in, so you don't have to install any weird extensions like you would have with Node.js or some other JavaScript runtimes. So that's the main reason why I chose Deno. But yeah, all it does is that it will save all those article headlines in articles into a SQLite database called Headlines 2024. And then we're good to go. In this case, I ran this a few months ago, so it was from January into August, so it was eight months worth of articles, and it's around 15,000 headlines. So not like too big. It could fit in like a Google Sheet or an Excel workbook if you really wanted to, but it's a small enough data set where we can embed it on the fly and kind of work with it a little bit faster. sqlite-vec and FTS5 can search through millions of records if you really want to, if you tweak some settings. But in this case, we just want a quick little demo. 2024 headlines should work out just fine for what we need. So again, this is just a scraper, gets the data that we need, and now we're going to build the full text search and vector search index on top of that. And that's what we do in this notebook. So again, we have the SQLite database that has one table called articles that has headlines, one headline per article, has 14,500 articles. So what this Jupyter Notebook does is that it will create the full text search index using the SQLite FTS5 extension built in. And after that, we will build a semantic index using SQLite-vec. One thing I forgot to mention, a link that I will drop in the chat. I have a, so one link I just dropped in the chat, it is a Google Doc with links that link to all of the stuff that we're going to talk about today. It has the blog post, it has the CVE, the security vulnerability that was found, as well as links to all these other things that I will talk about in these notebooks. So the full text search documentation from the SQLite team, links to SQLite-vec, links to the embeddings models we use and all that. So go ahead and save that. We'll also have a link to the recording for this event once it is out later today. It also has a link to the previous events that we hosted last month and the month before that with the launch party and binary quantization, all that. So make sure to check that out. But what we're doing here, back to the code. So we're using pure SQL to create this full text search full text search index. FTS5 is the newest full text search extension that is built directly into SQLite. You should use this over full text search FTS3 and FTS4. It is the newest version. It's pretty great. I've had no issues with it. So in this case, we're building a full text search engine around articles. We're going to have a headline column where we store the actual contents of the headlines itself, because that is the text that we want to search. We are using external content tables. This is a little bit into the weeds here, but what this does is we don't want to double store the headlines data into both the articles table and the full text search table. So what this does is that it will tell the FTS extension to look up the contents of the headline, look up the contents of the headline contents into this table instead of other places. So it's just a little optimization technique that we use here. We could insert the data from the articles table directly into the full text search table, just like that. And we could optimize the results after that. And after that, we have a full text search index. We can use this, for example, in a query like so, and this will do a full text search of the headlines that we have saved in this SQLite database. In this case, we do a match query on the headlines column because we want to perform the query Planned Parenthood for all the headlines that exist in this data set. And we can see here there are two headlines that match that, right? Kamala Harris visits Planned Parenthood clinic, and former Marine firebombed Planned Parenthood clinic. Wow, I did not read that through. I probably should have. But anyway, this is a full text search results, matches the exact phrase that we had with 2 articles that exist in this entire database of around 15,000 articles. So again, full text search, the exact queries that we use, that's what we get back. What we now want to build on top of this using SQLite-vec is a semantic index. So what this does is that instead of finding the exact phrases that we use, it will do more of a vibes search, right? So in the case of Planned Parenthood, maybe we want to see articles that have to do with abortion rights or women's rights or reproductive health, things of that nature, right? In this full text search example, we don't get any of that. We just get exactly what we search for. So what a semantics index can do, which we can build with SQLite-vec in an embeddings model, is that's more of a vibe-based search of like kind of in the area of what we kind of want as a query, not just the exact phrases that we look up. So we're going to do this in this case using SQLite L-embed. Now what SQLite L-embed is, I'll share a quick. We can do a quick look at what that is. So SQLite L-embed is one approach of generating embeddings from text. So what we have here, so SQLite L-embed, this is a separate SQLite extension to SQLite-vec. SQLite-vec, all it does is store embeddings and does embeddings distance computations. It doesn't actually generate embeddings for you. You could use, OpenAI's models if you really want to generate embeddings and store those in SQLite-vec, or use Ollama or Llama-file or any of those other embeddings providers that are out there. As long as it returns JSON or a blob, you could store that into SQLite-vec just fine. But in this case, we're going to use SQLite L-embed just to keep everything in SQL. This is a separate SQLite extension that uses llama.cpp to generate embeddings. So what you can do is you get an embeddings model in a gguf file format, so just a single file for an embeddings model. You configure SQLite L-embed to use that, and you just call in a single SQL function called L-embed. You pass in the contents you want to embed, and it will return a blob for you that you could directly enter to SQLite-vec. It is probably not as fast as some of the other options that are out there, but if you want to keep everything in SQL, it is a pretty good option. gguf files are a little bit hard to find, but once you do, all you really need is a single extension, SQLite L-embed, a single embeddings model file, a gguf file, and that's all you need to generate embeddings, which I think is much easier than hitting a REST API or hitting OpenAI's thing or downloading a PyTorch model and that takes minutes to download, all that other crazy stuff. I find this to be much simpler, and it's all in pure SQL. I don't need a Python script or Node.js script to do it. That is just one approach. You're more than welcome to use what other embedding services you have. But in this demo, we're going to use SQLite embed, which I will move up to over here. Let me change my screen. Oh, one question. Could this embedder run on device in small cloud VPS or need GPU? SQLite L-embed runs on anything. So it currently just runs on CPU. So there are pre-compiled extensions you could download on the GitHub releases. So if you go over to GitHub releases, you could download pre-compiled extensions through there. It is also on NPM, Python, Node.js, all that stuff. So similar to SQLite-vec, you could also install SQLite L-embed in similar ways. It could run on your laptop, and you could put it on a VPS if you really want to. It doesn't work on WebAssembly yet. That is one thing that doesn't work. Although I'd probably recommend using transformers.js if you want to generate embeddings in the browser. It's probably going to be much faster, and it works works out of the box much easier than SQLite L-embed. But yeah, SQLite L-embed you can run anywhere. It's very similar to SQLite-vec, just not in a web browser quite yet. But okay, so let's go back to the Jupyter Notebook. I need to love OBS. There we go. So the way that we're going to do this, building a semantic search index on the NBC News headlines that we have. We're going to configure SQLite L-embed to use this embeddings model. Here I'm using Snowflake Arctic. So the Snowflake a team at Snowflake, they created an embeddings model open source that you can use called Arctic. Specifically, their medium version 1.5 model is pretty good, I would say. It's fairly small. Like if you do a quantized version like this, I think it's like 200 megabytes or so. Which is larger, it's just slightly large, but way smaller than a large language model or some of the other models that are out there. And its performance is pretty good. I would also say that it was trained fairly recently. If you use some other models that were trained a few years ago, it just may not know certain things about the world. So for example, if you have an embeddings model that was trained in 2019, it just may not know about COVID-19 or coronavirus, right? And it may not be able to to figure out semantic meaning behind queries new queries like those. And in the case of NBC News headlines where they're fairly recent events, it's kind of nice to have an embeddings model that was trained fairly recently because it will know more about those events and kind of perform a little bit better. So that's one of the main reasons why I chose Snowflake Arctic in this example. But what you could do is you could download the model with this, with this wget example to get the gguf file that you need. You configure SQLite lembed to use that as the default embeddings model. And all we need to do is create a sqlite-vec virtual table like before. So we're going to create a vec underscore articles table. We're going to declare a primary key that matches the same primary key as the articles table. We're going to declare a floating point vector with 768 dimensions, which is the dimensionality of this Snowflake Arctic embeddings model that we're using. And all we have to do is just insert directly into the vec articles table. We use lembed right here, so this is embedding the text contents of the headlines column. It is returning a 768 dimensional floating point vector, and we can insert that directly into vec articles. Now this runs a little bit slow because it's doing one embeddings at a time. On my old MacBook from 2019, this took around like 15 minutes, which is pretty slow. But on my newer Mac M1, it took like 2 minutes and 20 seconds. So it's pretty quick for, it might be a little bit slow if you compare it to these like monster API services that are out there that could do, multiprocessing and, whatever, multiprocessing across multiple threads, across multiple machines on GPUs and all that. But I would say that on my Mac Mini, 15,000 embeddings in like a little over 2 minutes is like pretty good. I can just leave it running while I go have lunch or something, and for like small data sets, it usually works out pretty well. So that is one approach of using SQLite lembed to generate embeddings, storing it in a SQLite-vec table, and now we have a semantic search index. And one way that we could query this table using just vector search is something like this. We perform a match query on the headline embeddings column. We're using lembed again to embed the query that we have, Planned Parenthood. We're matching it, doing a k-end style search to return the 10 closest vectors that are in the database to what we have. And these are the results that we get. So if you remember from the full text search results, we just got 2 entries. We got this one about Kamala Harris visiting Planned Parenthood and a more dark one that might be down over here. But in this case, we get 10 results. So it is queries that kind of match Planned Parenthood. It may not say Planned Parenthood, but it will have some semantic meaning to that. So for example, something about the Dobbs decision, right? Or transform or healthcare, or Trump's changing positions on abortion. So these kind of have to do with Planned Parenthood. It might be something nice. It might be a nice result that you expect, but it doesn't exactly say Planned Parenthood. So again, this is a benefit for SQLite-vec using vector search with SQLite-vec. You kind of get more vibes-based results based off the query that we have. But again, just having keyword search isn't enough, and just having vector search isn't enough. So now we can talk about different ways where we can combine these two strategies, both a full text search query and a vector search query, and combine those results and kind of get better results for whatever use case that we have. So now we're going to go over to this other notebook, which, by the way, I will drop links to these notebooks in the Google document. These notebooks just exist in the SQLite-vec repository if you go under the examples directory and then NBC headlines, but I'll make that more clear in the Google Docs page with all the links directly to these notebooks if you want to take a look. And these are also described in the blog post that I talked about earlier. A link to that is also in the Google Docs description. Oh, one question, can you exclude a search term? With FTS5, yes. There is a Boolean option, so I believe you could do like, Planned Parenthood and not Kamala Harris. And then, so there is like some query syntax that the full text search, that the FTS5 extension provides. It's called Boolean searches. If you go to the link to the full text, to the FTS5 extension, there is a part of that document that talks about Boolean searches and doing exclusions. There's also like near phrases and like other bunch of there's a lot of features for FTS5 specifically if you wanted to exclude search terms. For vector search, not really. You could do like vector operations. So you could take one query like, Planned Parenthood and another query like Kamala Harris and embed those separately and then subtract those embeddings. Kind of like the classic example of king minus man equals women. You can kind of do that with SQLite-vec. There are scalar functions, vec add and vec subtract, if you want to try that out yourself. I haven't done it. I haven't seen how that performs. I've heard anecdotally that sometimes that kind of vector arithmetic where you add and subtract vectors together don't perform very well on certain embeddings models. So like try it out yourself. But it is, if you want to exclude terms, it is possible with the SQLite FTS5 built-in extension. Just check out that documentation page for more details, which is in the Google Doc that I shared above. So yeah, go and check that out. It should be possible. But okay, so let's combine these two, vector search and full text search. So this is a new notebook, so we're going to do a very similar thing. We're going to load in SQLite lembed. We're going to configure it to use the Snowflake model that we were using before. So again, as a primer, full text search, if we just want to do a full text search query, it's something like this. Select headline from FTS articles. We do a match query on the headlines column, and then we get the results that we want for full text search, exact phrases only. And then we have a vector search query where we do a similar thing. We do a match query using lembed on the headlines column, and we return the 10 closest KNN style vectors to the query that we had before. So to combine these two, there are a few different ways of doing it. The queries are going to be the same. So the query that you see here for vector search and the query that you see here for full text search is going to be more or less the same. We're just going to have different joins and different order by operations to kind of combine them in different ways depending on the use case that you have. So the first combination technique I call is keyword search. So this is something like you expect keyword searches to happen first. So you include those first in the results, and then any remaining results that you may want is vector search, right? So in this case, what we're doing is we are doing the same full text search query that we had before. So we're doing a match query on the headlines column on the FTS articles table. That is one step in this SQL statement for full text search first queries. The next statement or the next step in this CTE is going to be vector search. So again, the same exact vector query that we had above, where we are matching on the headline embeddings column using SQLite lembed. And the way that we combine them in this case for full text search first results is just a union all. So we get the full text search matches that we had before, and then union all the vector matches that we have. And there we have it. Now we have a query that returns the full text search matches first and then augments the rest with vector search. And this is an example of what that looks like. So again, full text search, those are the first few results of, in this case, we're querying for where the query is abortion bans. So those are articles that specifically have the word abortion bans in it. And the rest of the results have something to do with abortion or reproductive rights. It may not say abortion bans, but it's something kind of similar. I'd say this is what I expect in most search engines. When I search for something, it should be the first result that I get back. In the case of Adventure Time at HBO Max that we talked about before, this is what it probably should have been, right? You search for Adventure Time, you get the exact search, you get the exact TV show that says Adventure Time in it first, and then you could augment the rest with vector search, right, with the other adventure-related TV shows. So in my mind, this is probably what you want to try first, like full text results first, and then vector results next. That's what I would expect from most search engines if you're building something like that. So that is one approach of how you can combine full text search and vector search. Another approach is going to be something called reciprocal rank fusion. So this one's a little bit fancier. It's very similar that in the case that it is one big CTE. So again, we do a very similar, we have one step that does vector search using the same query that we had before, another step that does full text search using the other query that we were using before. And the combination technique that we use here, the goal of reciprocal rank fusion, gotta love acronyms. The goal of this one is to kind of interleave both vector search results and full text search results, upranking the ones that are both full text and vector search matches, so those appear first, and then kind of interleaves the other ones after that. So in this case, where we are searching for the query abortion ban, the top results that we get are both vector results and full text search results. So for example, this first article, Trump signals support for national 15-week abortion ban. So this was actually the second result in the the second ranked result in the vector search results. And this was the third ranked result in the full text search results. So it wasn't number one in either of them, but because it appeared in both the vector results and the full text search results, it's ranked higher than all the other ones. Same thing with the second result. It wasn't number one in either of them, but since they appeared in both, they're ranked higher. And then after that, they're kind of like interwoven together. So in this case, number 3, it was only a full text search result. So that appears next. and then the vector ones, and it's kind of interwoven between there. In this case, you could use vec rank and FTS rank as a signal for how these are kind of interwoven. Vec rank is the rank of from 1 to 10 of the KNN style results, where number 1 was the closest ranked result in terms of vector search, in terms of vector distance. And FTS rank is the same thing for full text, for the full text results. So number 1 is the best ranked result, number 10 is the least ranked result. So you can kind of see how RRF kind of interleaves both vector search and keyword search together to kind of build a more richer search experience. This is pretty popular. Supabase, this is what they recommend if you're using PG vector. I would say that the results are pretty intuitive, I would say. It's kind of nice to have query results that are kind of re-ranked by semantics, which is kind of comes out of the box with this. One nice thing about this SQL query is that you could also configure it a little bit. So if you want to weigh full text search results higher, then you can just change this weight parameter to like 2.0 or something. Or if you want to rank vector search higher, you could also change the parameter here. So it's like pretty configurable. The CTE is a little bit large, so it's kind of a little bit of a scary SQL query to look at, especially this one right here. This is where the combined rank happens. But for the most part, it's not like that. It's not too scary. And once you get the hang of it, it's pretty easy to do. It's very nice that it's just one big SQL query, so one big select statement, and you can do this this reciprocal ranked fusion kind of you can get those results. So it's pretty nice to have, and honestly, it's probably the best default to try if you want to have like some form of hybrid search. That just try RRF. If it works out, that's great. This is probably like the most common approach that you'll see when people are trying to combine full text search and vector search results. The last technique that I'll talk about is slightly different. So what this does is that it just does a full text search query. So again, this query, the same one that we had before, we were doing a match query on the headline columns on the FTS articles table. But instead of combining that with vector search results, we instead just reorder those results based off of semantics. So we get those headlines, we get the top 10 closest full text search results, and then we embed those headlines and then do a comparison of those 10 headlines with the query match itself, and then reorder those based off of how well they match the semantic query. So in this case, as you can see, we have a query for abortion ban where it returns 10 results, and we re-rank them based off of semantic meaning, right? So in this case, the first result was actually number 3 in the FTS ranking. What's surprising here is that the 10th result is now number 3. So it kind of re-ranks based off like how close it is to the query. This may not work in all cases because again, one, it requires a full text search match. But if you have a query that returns a lot of full text search results, then it's kind of nice to kind of reorder that by semantics, right? Again, depending on what you're doing, I would say this might make sense if you're building like a RAG application on top of like internal company data, right? Where like internal company like projects communications, they might have a lot of like code names or secret words or like IDs that are good full text search matches. But then you want to like reorder those based off of vector search, right? So if you just did vector search on those things, it wouldn't catch it because those like rare words. So for example, you might have like an internal project name in your company called like Project Orion, right? Everyone calls everything Project Orion. These embeddings models don't know what Project Orion is. It'll probably assume that it's about like constellations or something. But you know that Project Orion is like an internal company thing, right? So you're going to want keyword search to find all those documents that talk about Project Orion. But after that, you want the results that have to do with your query more, right? That you want Project Orion end date or whatever. And that end date you won't get from like that query that you have of end date won't appear from full text search by itself. So then it might be nice just to reorder those by vector search and kind of, see the most appropriate ones first. Again, depends on your application, which combination technique that you use. But that is one that I was kind of experimenting with that might make sense in some contexts. So yeah, so those are the 3 combination techniques that I explored in the blog posts and that I have in these Jupyter notebooks. Again, I would probably say that RRF is probably the most common one to use and probably makes the most sense in most cases. And you could always just play with the parameters a little bit if you want to like kind of see how well they perform. But again, this all uses just the built-in SQLite FTS5 search extension and SQLite-vec, which stores vectors by themselves. You'll need some other service to do actual embeddings generation. In this case, we use SQLite-L embed for local embeddings, but you're more than welcome to use SQLite-R embed, or you're more than welcome to use remote embeddings or some other like service to do that. But yeah, it's very nice to have everything in like one SQLite file, because this file that we have here, I believe, I don't have it on this computer. This file, like just the headlines by themselves, just the scraped headlines, was around 4 megabytes. And then when we add vector search and everything else on top of that, and all the embeddings, which are quite large, it goes up to like, I want to say like 70 megabytes, which is quite large. But it's still a single file, right? And you could do all these queries, do all these experiments on that single file with just these SQL statements. And you're more than welcome to copy and paste these SQL statements into like a Python script that just, connects to the SQLite database, calls this SQL and returns results. Or, in Ruby or R or Node.js or whatever other, client library they're using. It's very nice to have everything in one SQLite database. One approach that I didn't talk about in the blog post, but we talk a little bit about here because we have some time. So that table or that SQLite file, what was originally 4 megabytes, and then we stored all the embeddings in there and then went up to like 45 megabytes. What you could do is use binary quantization to kind of slim that down, right? I would say by itself, a 45 megabyte file isn't like too terrible. You could, that could probably be an email attachment or a Google Drive thing, or you could probably compress it to make it a little bit smaller. But if you did want something, a smaller file, to pass around on in the web browser with WebAssembly, where you really have to worry about download speeds and how large your files are. One approach to do that is with binary quantization. So instead of storing 768 floating point numbers per dimension or per vector, you could instead store 768 bits. So binary quantization, convert those floats into bits. You will lose accuracy, you will lose some quality in those search results, but it will reduce it by like 32 times, right? So this part of the notebook talks a little bit about how you could do that. In this case, we made a copy of the database. We created a new new vec articles table using a bit vector instead of a floating point vector, which again is 32 times smaller. And all we did is use vec quantized binary, which converts a floating point vector into a bit vector and store those directly into the vec articles table. And after a vacuum, the file shrinks down to 7.1 megabytes, where the original was 53 megabytes. So again, much smaller, very good if you want to like throw that in a blog post or in a website somewhere and have people like play with it within their web browser. If you don't want them downloading a 53 megabyte file, which honestly by itself probably isn't too bad, but some people are on mobile devices or whatever, or slow internet, where if you could reduce that by that much, pretty good in some instances. So binary quantization can help out with things like this, and this part of the notebook talks a little bit about that if you're interested in that. But yeah, so that's the gist of it. That was, let me go back to the, let me switch screens real quick. Back to the presentation. Oh, wrong one. But yeah, so that was the demonstration that I talked a little bit about in the blog post itself. And those are a few different ways on how to combine vector search and full text search together. More than happy to answer any questions. If you also want to talk a little bit about like SQLite-vec in general, if you have any questions about SQLite-vec or keyword search, more than happy to do so. I would say there are still some limitations with this approach of like combining full text search and vector search. I think one thing that we kind of talked a little bit about before, full text search has a lot of features. The FTS5 extension has a lot of features that just aren't supported in vector search. For example, in the FTS5 extension, there is a highlight function where you could highlight based off of a document that's returned in a search query. You can highlight the specific words that were used. So for example, if you looked up Planned Parenthood, you could add bold tags around the term Planned Parenthood in a document to see like how the query relates to the document itself. That doesn't exist for SQLite-vec itself because all we get is a distance from like the query vector to the document vector, right? And that's just a number like 0.25. We don't know why a query is close to why the query was close to the document itself. It's just kind of like a vibe semantic thing that we have no insight to. So that is one thing that we don't have. We can't like highlight a passage based off of a query from vector search results. There are ways you could do this outside of SQLite-vec. So there are some embeddings models like Colbert and some other ones where you can take a take a query embedding, take a document embedding, and then on a per token basis, it'll give like which one weighs more. So you can kind of see like why a passage or a document relates to a query. But that doesn't exist in SQLite-vec yet. I'll support tensors at some point, but unfortunately it does not apply today. So first question, can I apply a where clause that filters on certain columns and then apply vector search? So using the vec0 virtual table, currently not. That is one thing that I want to include. I have a GitHub issue for that. It is actually within the Google document that I shared above that I will share another link to. So that is on my radar. So I want to have metadata filtering on vec0 virtual tables. So that way you could, add, just do a vector search on articles from January till now, right? Or just do it on news articles that are under politics and not sports, things like that, right? So if you're using vec0 virtual tables, that's not possible. You can perform, I'll find a link to this. So what you could do instead is you could just do manual vector comparisons, so just not use the vec0 virtual table. There are SQL scalar functions for calculating the distance between two vectors. So what you could do is just store vectors as JSON or as blob in a regular SQL table, perform where operations on that, and then just join it back. In that case, then you don't need the vec0 virtual table at all. You just do everything manually. I haven't talked too much about how this works, but there is a link in the documentation, which I will drop a link to in the Discord right now. So the link to it I just dropped, it is a section in the documentation that talks about how to manually compute distances using SQLite-vec and not using the vec0 virtual table. So if you were to do it the manual way, you could do metadata filters by yourself. So it wouldn't be as fast as the vec0 virtual table, but it should be fast enough. So you could just have a table where you store vectors inside of a regular SQLite table, inside of a regular column. You perform your where operations on those other columns that you care about, like date or category, whatever else. And then the remaining pre-filtered list, then you perform vector search on those manually. Again, it won't scale very well. So if you're talking about like, hundreds of thousands or millions of vectors, it would probably be a little bit too slow. But I think for some smaller data sets, that approach might make sense. But again, I am working on including metadata filtering in vec0 virtual tables. It should be happening in the next few weeks. I just want something that actually works well and fast. So that is one thing I'm working on. There is a GitHub issue for this. Let me find a link to that on over here. Metadata filtering. Cool. I just dropped a link to a GitHub issue for this issue specifically if you want to give that a thumbs up, and I'll provide updates on that GitHub issue whenever that appears. Another question that appeared above, are there any embeddings model trained on highly technical documentation, or are all the models roughly as competent as each other? I don't know. I'm not the best at embeddings models, to be honest. I would say that like it is easier and easier to fine tune an embeddings model for your use case. So I haven't really done much of this myself, but there are a lot of like Jupyter notebooks out there or third-party services where you can kind of do some fine tuning on an embeddings model for your specific use case. I haven't seen any like pre-trained models out there for like highly technical documentation before. I'm sure it exists, but also like if you're talking about like code documentation or like, open source stuff, I mean, there's so much training data out there. I imagine it wouldn't be too difficult to do yourself. But yeah, again, I haven't tried that myself recently. Another question, could you hack filtering with good performance by making separate tables for each filter? Yes, I think so. I think if you really wanted to like build separate indexes and pre-filter them and then do like some, vector search on top of that, you could do like a pretty good approximation or pretty good like way of like metadata filtering right now. I just don't recommend it because it's just like kind of convoluted and kind of whatever. But if you're motivated, yeah, you can have a index that does like pre-filters of like where clauses on, predefined columns, like, oh, make sure this article was submitted, in this certain time with this certain category by these certain authors. And then if you pre-filter that list using a bunch of, pre-configured indexes, you do that query, you get a small subset, and then with that small subset, you get embeddings for those rows, and then just do manual comparisons off of that. You could do something pretty fast. I just haven't documented it yet because again, I think it'll be best when vec0 has like built-in metadata filtering support. But maybe I'll probably add a page in the documentation on how to do that approach this week. Yeah, I've just been kind of lagging on it. I'll post a comment in the metadata filtering GitHub issue when that appears, just if you want to work around for something that works right now for metadata filtering. I'll do something for that this week, so look out for that as well. LangChain integration. Yes, thank you, AJ, for getting that to work. Hopefully that comes out soon. Really looking forward to it. I can't imagine the hellscape that is Pydantic and LangChain with all those Python packages that they have. For you folks that aren't familiar, so they're AJ and a few other people have been working on a LangChain integration for sqlite-vec. It was currently merged in, but I think we're just waiting on a new release of LangChain for it to actually be to be usable. So if you are in that community, if you do like using LangChain, then sqlite-vec will have support for that relatively soon. The fact that this works in a web page via WebAssembly, I agree. It is very cool. I really like it. I think having something that where you can train or build a semantic search index using the techniques that we talked about in something like a Jupyter Notebook, where you really have the beefy, whether it's on Google Colab or some other custom instance, where you really have like the beefy, CPUs or GPUs to do all the embeddings generations and just saving that to a SQLite database, and then using that same SQLite database and just throwing it on a web page or in a Node.js app or a Python app and be able to query it. That's pretty cool. I think a lot of other like vector search tools that are out there, it requires like a custom SDK for everything, like there's an SDK for Python, an SDK for Node.js, and they all have their own different API and their own different features, and it's a little bit weird, whatever. One nice thing about SQLite-vec is that it's just all SQLite, so all pure SQL. It works in all these different environments, whether it's, a Jupyter Notebook in Python or web browser in WebAssembly or a, Raspberry Pi or mobile device or Android or iOS. It is really nice having a unified API that is just pure SQL that works everywhere. So that's one of the main reasons why I love using SQLite-vec. Oh, so good call out. So actually with SQLite LEmbed, I was working on batch embedding support this weekend. I did get something like almost there. So that will be available in SQLite LEmbed very soon. I would say it didn't. So for those of you who aren't familiar, so SQLite LEmbed, the examples that we saw today use the lembed function on. It would just call we would call lembed on every single headline and every single row in the articles table. So it just did one lembed after the other. It just like sequentially one after the other, just one on a single thread. That's pretty slow. So we've been wanting to include batch support where we could take like a batch, it would do like 20 rows at a time because the underlying embeddings llama.cpp inference engine is pretty good, like parallel stuff. So I did include batch support, but on my own benchmarks on my Mac and on my Mac Mini, it's not as fast. It's not much faster than I thought it would be. I was thinking it'd be like 2, 3, 4 times faster using batch embeddings than like regular ones. But I was only able to get like maybe like a 50% increase in speed or something like that on certain queries. So it's not as fast as I would hope, but it might be fast enough for certain things. So yeah, I'll probably get a PR up and merge that into a new release of SQLite embed shortly. I'll also get it for SQLite REmbed as well. I think there it will have much better support. So for those of you, to talk a little bit about SQLite REmbed, so SQLite LEmbed, the one that we're using today, is about local embedding. So using llama.cpp and using like your own local machine to perform embeddings. SQLite REmbed is for remote embeddings. So if you're using like a remote API source, like say OpenAI or LlamaFile or OLlama or anything like that, SQLite REmbed is a very similar SQLite extension for generating embeddings, but it hits those remote APIs instead of performing them locally. So again, it has the same problem. If you call REmbed on every single row in a table, it will do one HTTP call, wait for a response, then do the next one and the next one. And that really slows things down, especially if you're using like a remote HTTP endpoint. So I will include batch support for SQLite REmbed as well. I hope that will be much faster than the speedups that I saw with SQLite LEmbed, mostly because like HTTP requests take like way longer than like local inference. So that will be coming soon to SQLite REmbed as well. So yeah, hopefully that helps you out, Matt. And yeah, I'll definitely include documentation for manual metadata filtering relatively soon. Go ahead and follow that GitHub issue if you want notification for when that comes out. And of course, for everything else, for all other notifications about SQLite-vec, the SQLite-vec Discord channel, always there, happy to answer questions there, and I'll also post updates on these as well. So yeah, I'll stick around for about a minute or so. If anyone else has any questions, I'm happy to answer anything. Again, after I will drop a link to this Google Doc, to the Google Doc containing links to everything that we talked about in the SQLite-vec channel right after this. And I will upload this recording very soon if you want to share it with other people. Again, check out the blog post linked in that Google Doc that talks about exactly what we talked about today, but in a more, formal text-based link if you want to share it with other people as well. The next event will happen in the next few weeks. I'm still trying to figure out what I want to do. That event will probably either be about RAG, so using LlamaFile and SQLite-vec together to create a RAG application to, for search over private data or for private documents, all local, all on your machine. Or it will be about metadata filtering. Depends if I'm able to do metadata filtering and partition by support by then. So trying to figure out which event will come first. But otherwise, next few weeks, look forward to another online event. We'll post about it on the SQLite-vec Discord channel, LinkedIn, Twitter, all that stuff as well. Happy to answer questions in the SQLite-vec channel after this, and hope you all have a great day. See you all later.